Hi, my name is Leah Abribat, and this is my term project. An interest of mine has always been why humans have only discovered 95% of the ocean, but I've never given it much thought and research. My research project is devoted to what new technologies are currently being developed to explore new depths and regions of the ocean. Why does it necessarily matter what's at the bottom of the ocean? Well, partly because researchers just want to know, but more importantly, the bottom of the ocean could be a new, valuable resource and be very beneficial in modern day society. Matter of fact, according to a report by the World Economic Forum, the deep seabed has many different minerals and metals that could be very beneficial to human life up to depths of 5,000 meters in the ocean. What is sonar? So sonar stands for sound, navigation, and ranging. It's a technology used to recognize objects underwater, and it recognizes sound waves to identify and see underwater. According to oceanservice.noaa.gov, sound waves travel much further in water than radar and light waves. There are two types of sonar, active and passive, and active uses pulses and echoes to receive signals, while passive detects noise, but doesn't have a signal. The sonar system uses physical sound sensors called transducers. A group of them can be attached to underwater vehicles. As you can see in this picture, the transducer senses a seabed and converts it into an electrical signal. The transmitter modifies the electrical signal and sends that signal back to the receiver. So you can see the transmitter and the transducer in this picture. These are real-life sonar pictures. Different teams from around the world are actually competing against each other right now to win $7 million in the Shell Ocean Discovery X Prize. Whichever team creates the fastest, safest, and cheapest technology in exploring the depths of the ocean floor wins. Germany's team has created an entirely new technical approach for this competition. The vehicle uses sonar technology to create maps. They are also equipped with cameras that take visible pictures when it's dark by using LED flashlights. Down below is a quick video on how the model works. We're just going to watch like 20 seconds.
Our diver operates as part of a swarm, so we can map a large surface area in a very short space of time. The individual maps are subsequently assembled into one big map. They are compiled with sonars that generate sound waves. The sound is then bundled and reflected in a specifically defined direction. The travel time of the echo enables us to calculate the position of a reflecting object and the nature of the seafloor in three-dimensional space.
Let's see. And then the team from Japan is taking a different route that involves a fleet of unmanned robotic vehicles. They have produced an anonymous surface vehicle that is linked to an anonymous underwater device. These devices can search the ocean floor at high speeds, which will allow them to investigate more depth in less amount of time. A team from Duke University has heavy aerial drones that drop retrievable diving sonar pods. After these pods scan the bottom of the ocean, they can then send information back at regular intervals. A team from France has brought nature into their design and has similar characteristics to a bee. These micro-robotic submarines map the ocean floor but operate from surface ships called hives. And then these are my references.